Okay, so in the last example, we were solving an equation where we had a half angle, half coefficient, and of course that reduced the number of things we look at. We're going to look at another one where we have some addition with the angle as well, except this time we have a bigger angle. So let's consider the equation here. Sine of 2 theta plus pi over 2 equals negative 1/2. Okay. So once again, we need to build up our new angles that we're going to be looking at. And so in this case, we start out with the basic 0 less than or equal to theta, less than 2 pi. Right? And we need to build this up so it becomes 2 theta plus pi over 2. So we take care of the multiplying first. So that's just standard order of operations, right? Multiplication comes before addition. So we multiply everything by 2 theta, which will make that not 2 pi, but rather 4 pi. And then we add on a pi over 2 to everything. So we're going to be looking between pi over 2 and 4 pi over 2, 4 plus pi over 2, or 4 and 1/2 pi. I could write that as a mixed number, but here it's better to think of it as 2 full turns plus a half, plus another quarter turn, or as 4.5 pi. It's just easier to think of it visually as we go around that way. Okay. So once again, same process as before. Replace that stuff with a dummy variable u. We then need to figure out our reference angle, because that's not a quadrant value. If that was a quadrant value like 1 or 0 or -1, right, then we wouldn't bother with a reference angle. We would just start using the unit circle definition to figure out the ones we need. So here we have sine u equals -1/2. That is an exact value. So remember that is pi over 6 that would give us a 1/2. Okay. We're then going to take that angle and we're going to plug that in to the quadrants where sine is negative. Find first the answers that are acceptable between one full turn, and then first find coterminal ones to get the expanded range here. So sine is negative in the third and fourth quadrants. So I plug that reference angle into those quadrants. And so our first angle would be pi plus pi over 6. It would be 1 1/6, or 7 pi over 6. And the second one would be short of 2 pi. 2 minus 1/6 would be 11/6, so 11 pi over 6. The pi over 2 doesn't actually factor in here as a limitation because we're the third and fourth. But what that does X out is on the first full turn, we would exclude the pi over 2. Anything before pi over 2. Now that doesn't matter here. If this had been a positive 1/2 in the equation, then we actually would have been leaving out pi over 6 on that first turn. And then we would have to go around a third time to get that pi over 6 angle, because we would be in that, we would be starting 1, 2, and then back again with that. So we would have that additional angle. Okay? It would actually be like this. There's one turn, second turn, and then stop. And that's where the 4.5 would have come in if it had been a first quadrant value there. but that's not an issue in this case, so we don't have to worry about that. What we do need to do now, though, is find the other angles between 2 pi and 4.5 pi. So we add on 2 pi to each of those. So we take our 7 pi over 6, add on 2 pi. Again, that's going to be 2 and 7/6, which will be 19 pi over 6. And we take our 11 pi over 6 and do the same thing. And that will give us 23 pi over 6. The next time, if we tried to add 4 pi on, that would be 4 plus 7/6. 7/6 again is 1 and 1/6, so that would be 4 plus 1 and 1/6. That would actually be 5 and a 6th, which is bigger than 4.5. So the next time around would just be too big. Okay. And then we just take our original angle, 2 theta plus pi over 2, and we set it equal to those 4 values. And then we have the work of essentially solving these 4 equations, although the process of solving them is really just the same process repeated 4 times. Right, so to solve now for theta, we would have to subtract off our pi over 2. And again, I really encourage you with these arithmetic problems here to think of that as just subtracting off a half. So when you do the arithmetic, 7/6 minus a half, yeah, just take care as you're doing that. You can, of course, write those out, right, where you get a common denominator. Right, and work through the process that way. That will give you 4/6 as your first answer there. Or, if you have calculators, mine does a pretty decent job of it. A lot of scientific calculators nowadays will actually do those answers for you and let you display it as a fraction. So whichever works for you there. I'm certainly fine if you have some technology to help you out there that you can use. Go ahead and definitely use it. Save you a little bit of time. Keep you a little more accurate. So we do that. We subtract off 1/2 from each of those different things. 1/2 would be 3 pi over 6 with the common denominator. So that gives me 4 pi over 6, which would be 2 pi over 3. The next one would give me 8 pi over 6, which would be 4 pi over 3. And then 19 would give me 16 pi over 6, which would be 8 pi over 3. And then 23 would be 20 pi over 6, which would be 10 pi over 3. Right? And then each one of those we'll need to solve by getting rid of the 2 theta, which we can do by multiplying everything by 1/2. Multiplying everything by 1/2. Okay. So that will give us theta equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And of course, all of those answers for theta do fall between 0 and 2 pi as we need them to. They do fall where we need them to. And that's again why we go through that initial process to make sure that we find those answers that we need to find.